Just
went.
curious as to why. Why do you want to keep this ideology, this concept?
Oh, why?
Yeah.
Because, like, okay, so again about models, like when you make the globe model, like it doesn't explain everything. It explains the weather, explains the moon,
There is
the
no globe model.
yeah. I mean, yeah, there is. The
No,
sun's at the center. It orbits around the sun. The moon orbits
no.
around the Earth.
We have to be careful about the terminology that we use. It's only a concept. It's a mathematical concept. There is no model.
So is a model meant to be? I thought a model was just like a visual representation of a idea.
Well, yeah, if it's a die-cast model of a Ferrari, then yeah, it's a smaller representation of an actual thing. But in this case, because the actual thing doesn't exist, it's purely mathematical. It's just a concept. And besides, if we're talking about science and scientific models, then there would have to be experiments being performed, which there are not. So this is only conceptual in the mathematical sense.
You have to have to buy an energy. Do you have to have ID in America
To what?
to buy an energy drink?
Do you have to have an ID? No, but there are some energy drinks that recommend that people under 18 do not purchase them. It'll say it on the can.
Yeah, like a line. Red line is monster, by the way. Hard.
Is he cutting out for anybody else, or is it just me? Beanie Weenies, you're cutting out. I don't know why.
Okay, there we go. That should fix it. Yeah. What was like red line? Red line is monstrous. I've heard horror stories.
Red Line or Red Bull?
Red line.
Never heard of it.
It probably got banned because it's genuinely like it might kill somebody. It probably has killed somebody.
So when it comes to the heliocentric concept, you are more
Yeah.
comfortable with a mathematical concept that in reality does not exist because it answers questions for things that occur in nature?
I mean, yes. Like it explains why the things happen. So
Well, see, explanations
appreciate.
are worthless unless they have demonstration. So an explanation in this case would be a just so story, or kind of like a fairy tale that someone would tell you. Like Santa Claus,
Okay.
like you see the presents under the tree, so your mom and dad tell you that he came in the middle of the night down the chimney and put them there. It's the exact same thing as the globe. You see an eclipse, they create some kind of elaborate story about where you live and space and all that, and show you how it could happen, and so you buy it. So it's essentially the exact same thing as Santa Claus, although in reality, none of that is true.
I hate that. I see the analogy. Um, I don't want to say good point because that all sounds crazy to myself.
Well, I mean, digest it. But like I said, this is all purely mathematical. It's just conceptual. But you have to go to the actual Earth to see its, geometric properties. You have to measure it. That's reality.
Yes.
The flat earthers are the only ones that are saying things like, I don't know. Like if people come in here and go, well, how do you explain how eclipses work? Ultimately, I don't know why the moon gets darker and the sun gets darker at certain times. I have no idea. There's no way for us to test that. But we do know in reality that the earth is measured to be flat. So the best we can say is, I don't know. You know, I don't even know what the sun and the moon really are. They're light phenomena in the sky.
Oh yeah,
I
is
see
is
what you
that
see.
yeah? Is that like the universal view of like not universal because like obviously you can have like different people different thoughts, but like is it the main view of flat earthers that you generally don't assume what you can't know. Like you don't know what the sun and moon are.
I would say overall, no. I think it's going to be the vast majority of people that consider themselves to be flat earthers that are going to try to come up with another just so story as to how it works. Those of us who kind of hang around this particular server, the 24/7 Flat Earth Discord 2.0, we do our best to make sure things are empirical, so that we don't just go making up stories, because I don't want to replace the bad story that you already have with another bad story.
It's not an attempt to do that anyway. It's not an attempt to explain every single little thing that's happening in the universe, right? It's an evaluation of the surface geometry. That's it. Plus, well, it's not that's it, because we evaluate other aspects about it, like it's claimed to be moving, but we don't sense that. Nobody measures it, right? That's just an assumption based on philosophical preferences. And we scrutinize the idea that we exist as an object floating in an ever-ending void. Never-ending void, sorry. So while we're not presenting an overall cosmological viewpoint per se, we do scrutinize the one that already exists, which does claim to answer, oh, wait, what is it? Only 6% of the physical universe. That's what did Neil deGrasse Tyson say? We're 96% dumb or 94% dumb or something?
Probably.
And other theoretical physicists and astrophysicists have said, yeah, we really don't know shit. But then people come in here so confident that it's all true. Why can't you guys just deal with what we actually are claiming and not the things which you claim, and then demand we also make a claim about those things? We're just pointing out that the surface isn't curving. There's no measurement of it, and any attempt to measure the surface results in nil curvature.
Oh,
but we're
yeah.
so small. That's not my problem. That you think that we're on a big ball that's so big that it just appears and measures flat. It's not my problem. It measures flat. Get over it already.
I mean, that's it.
Yeah, I forgot. That's one thing I meant to do. I meant to find a paper that does measure the Earth is flat, because there probably exist some that do claim we measured the Earth flat. So I wanted to
Well,
find one of
Bean,
those and bring them to you. See what you say about them.
I'll give you something. Yeah, go type in like a country or a state, like Florida, right?
Yeah.
Topography, Florida topography. Enter. There is a English dot something topography. It's a great site. They have the topography measurements from all of the surveys done all over the world, and it's mapped out for you.
Yes.
So the coastline, I mean, 0 is what color it is. Elevation above 0 is the color it is. Red is the highest. So you can kind of figure out elevation from there, and it's basic. Same thing as a 3D model, right? If you flattened it out the other way, you have you got a sim at that point.
Assume what?
Well, I mean, 3D simulator, like flight simulator, helicopter simulator, if you take the topography, right, from what we've actually measured, and just, instead of being on a flat screen, you lay it down like it's supposed to. Ta-da! You have the starts of a 3D simulator for literally anything.
I don't get your point.
Well, the topography shows the coastline of Florida being level all the way up from the top to the bottom.
What do you mean by level?
I mean, there's no deviation.
Okay.
But that's your mean, right? That's your mean sea level. That's
Right.
what it is when the water isn't moving.
That means sea level is equidistant center of the radius.
Oh my god, that's why they use sea level. I don't, that just clicks for me. That's why
The
they use sea
tide
level.
goes out, the tide comes in, the average between them is the mean.
Yeah.
That's your level, that's your zero.
The average
From
Yeah.
zero,
distance from
now
the
you're
center of the
looking,
Earth.
elevation is upwards, right? And deviation is downwards. Now you have a zero. You start off with a graph, and then you go from differential leveling all the way down the coast, and now you're checking to see whether you have elevation upwards or deviation downwards. And that's all you need. All you're doing is going back with the differential leveling tools and fact checking the guys who actually did the survey in the first place, which is absolutely great. Go do it. You'll be in here on my side in no time.
Perchance.
Oh, bro, I have a background in commercial construction, commercial plumbing, concrete, entry access. We did all kinds of different stuff at different times. Using surveying equipment is number one thing for most major commercial construction companies. Differential leveling. I guess, does that help you with your questions, Being Toasty?
Yes. Ooh.
I mean, I got guys in other places that have been in the debates a bit longer on the globe side, and they're trying to use differential leveling as if they're measuring height, breadth, depth, width of anything, right? There's no actual measurement there. They're just getting an angle. And an angle doesn't measure in inches or millimeters height. Doesn't do nothing. So it's not a... It's just a sidebar that they think makes, their imagination reality.
Well, if you have an angle measurement and a measurement of distance, then you can calculate the height.
That's a whole nother thing, like looking at something off in the distance and trying to get something. There's still your level. You drop your plumb bob, you make your horizontal, you have your baseline, which is your horizontal. So it's not like you have some kind of curvizontal line that just wiggles and squiggles as it goes off into the distance.
Oh.
Yeah, but on the globe, they call level is like curved, right? So if you
Yeah,
use the word
cool.
level, globe earthers will just think you're talking about level in relation to a globe.
That's true,
Well,
but they
yeah,
don't
cool.
use it like that. So when, like, for example, measuring the heights of mountains, they establish sea level, extend a horizontal line out from there, imaginary, of course, but they level their theodolite horizontal and then gauge how much that mountain, right, is above that horizontal. So all their calculations of the heights of mountains are wrong if the Earth is a ball. Every single one.
Well, off in the distance, yes. But here's the thing. I see them using terrarium aquariums. I don't see them using globe aquariums. I've never seen a globe aquarium in my life where they can get water to stick to something that's round all the way around and with fish inside of it, right? So I've never seen a globe aquarium ever. Only seen terrarium aquariums, which is what we have here, terrarium. Which, I mean, some people would call it a flat earth aquarium, basically, because you're dealing with a box, which is all flat earthers say that the reality is just an area that we exist within that's contained. I've had fun with this one, right? Where is the globe aquarium? Where's the aquarium where you get water to stick to something that we suspend in the air where the fish can swim around this ball of water?
I mean,
Yeah.
Super curious.
the way they explain the water sticking to the globe is it not gravity?
Yeah, that's how
Okay,
you would
so then you
explain it.
should be able to make something then that does that, right? If we know what
No,
does what, we
Yeah,
should be able to recreate it on
hold
a
on.
micro scale.
Hold on. Sorry.
we
I've thought
can't
about this
because
for a while, these flat earth arguments, right? That we should be able to make a ball and spin it and make water attached to it. Remembering, because we always forget that we're on the earth and that we're going to be pouring the water down because that's the direction that the water is going to go. So whatever force is applied on the earth is going to behave and act upon the water that we're trying to attach to what?
Exactly. You
basketball.
have to isolate your experiment from the rest of
Yeah.
reality.
So
Well,
as
hold
our
on,
friend
I'm not
just said, within
not doing
that
the spinny
argument, the
part.
reason why the water goes down is because of the gravitational attraction or whatever, because it's a sphere.
Right. But you're talking about being able to recreate something. So
Yeah, but
whether
you
or not
can't on the earth.
right, but that's a presumption that we've still yet to get proven, right? That's the
No, it's
problem
not a
we're
presumption.
having.
I'm pointing it out. You've poured the water because the water goes down onto what? A ball, and the water is still going to want to go down and can't adhere to the surface that it's on that you're trying to get it to stick to because the water's going down because water always wants to seek its level, doesn't it?
Right, but what you're
Well,
telling
the
me
ball too wants to go down.
Yeah,
the
exactly.
Globers don't know what causes water to stick to something is what you're telling me, because then they
No,
should
he
be
just
able to
said it.
recreate it.
In his idea, it would be gravity. The reason why you do it with your basketball is because the basketball doesn't have enough mass.
Okay, let me rephrase this. If you know something does something, then you should be able to then recreate its environment or its action, right?
Yeah,
I can
So
do it for
then,
you,
but
but I
the
can't do it
environment
spinning.
of the Earth would impact the experiment. This is why you would have to go out of what is called a gravitational field to do this
Or create.
experiment where only the gravitational effect of the ball would be acting upon the water. How you're going to get water in a vacuum, I don't know, but this is how you do it.
I can't do it in a vacuum. I can do it in liquid, and I can't do it while the ball's spinning. But so this is theoretically. Like, it works in principle. Okay, I haven't done it, but if you have like a substance, alcohol substance, right, and it's of a certain viscosity and density, right, and you get a solid object which is of the same density, buoyancy, place it in that liquid, and then you could theoretically you could inject a another film of oil that's of a very close or exact density around that solid object, and then it will form a sphere. So you'll have a sphere of liquid around a solid object within a medium of liquid, another liquid. So it's not in a vacuum and it's not spinning, but it's getting closer, right? There you go, Globers. I've given you a tip there.
there's a lot of things, but the problem is what I'm asking for shows that they don't know what they're talking about when it comes to any of this. Because if you can't do it, then how are you able to explain it if you can't recreate it? Like, this doesn't make any sense. Either you know how it works and you can make it happen again, or you don't know how it works and something's being made up, right? Because it's like
One of the
you can't tell
variables
me
you
you're an
can't.
expert. Well, you're an expert, right? An expert gunsmith, and I hand you my rifle and it's having problems, right? But you don't know anything. You never went to classes. You never did anything. But you told me. It doesn't help me, right? I still have a broken rifle. If you can't produce results, then you don't really know what you're talking about.
We can't produce gravity because we don't have the mass on Earth to make gravity work.
Well, that's just an excuse.
How is that an excuse? Because the theory requires like such magnitude.
Magnetism or magnitude?
Magnitude. It requires like literal planet levels of mass and magnitude.
Well, now,
You
hold
won't
on.
do that.
I have to correct you. This is not a theory. This is a mathematical concept again.
Huh?
Gravity, just a mathematical concept.
Well, in this category, yes. In
Yeah.
the category of reality, it's just defined as weight.
It's a little too simplistic.
The amount that something weighs when it's put on a scale is more complicated for
Like
you.
gas that's going upward. How much weight does that have?
Well, that's dependent, though. You're trying to now push things more dependencies, and I mean,
No.
technically, us having a measure has dependencies too, but gas has its own. We're dependent on the pressure.
Yeah, but weight is definitely not gravity.
It's effective
That's
gravity.
not what my. Hold on. My American Standard English Dictionary from the 1700s says that's exactly what it is.
Well, I could care less what the dictionary says. How much does the gas weigh?
That's not the debate.
It isn't.
No.
Isn't weight exclusively a downward vector measurement?
Right, but gas doesn't really have what you would call mass, but it has weight.
I don't
And a
even know what
vector.
mass is.
Has a pressure vector.
Me either.
Has a direction of force, right?
Yes.
The brick has only one direction of force, doesn't it?
It can. Yeah, I mean, yeah. At rest.
Yeah,
basically.
yeah. Unless you pick it up and throw it at me, for example. But
Yeah.
if you were to let it go, right, it would only have one vector of travel.
Yes.
Gas that's got energy given to it by temperature goes in all directions. Its potential pressure vector is omnidirectional. Mr. Han, you're bugging me already. Are you trying to join the conversation?
No,
You
he's
good?
trolling. He's just here to make a bunch of noise.
So what's weight?
So go
Is
on.
that gravity?
So yeah, where was that going? So continue. The brick has one directional.
Yeah. Somebody said weight. That's
Yeah.
what gravity is.
No, it's
That's
effective
the
gravity.
definition. Well, that's
Gravity
the
is not.
definition that we define as an effect, yes. It's measurable. But the cause isn't gravity, that's the effect, right? So the cause still is yet to be determined, which proves my point. Nobody really knows what they're talking about.
The cause is determined of gravity.
What is that?
I was.
Well, at least
How
within
do
the
you hijack the effect to be the cause of
Hold on.
itself, bro?
Hold on. What is that cause that's been
I don't know,
determined
the
for
cause is
gravity?
simply the presence of mass. I'm pretty sure it's simply the presence of mass. It warps
So
space-time.
just the existence of mass itself.
Within the fabric of space-time.
There you go. Yeah. So the
Yep.
existence of mass itself, which is distorting the fabric of space-time, causing the
Yes.
objects that have a straight path to curve.
Yes.
So
You know
to
what's
prove
crazy?
this,
Oh no,
we would have to take some mass, right, whatever that is, still undefined as far as I'm concerned, and then get some space-time and see if it does indeed curve it. Now, where can we find this space-time at?
Everywhere, I
Oh, me.
guess.
Me.
Well, okay. Go ahead,
We
Jedi.
have a problem.
In mathematics.
There you go. Only mathematical. So not in reality. Do we have any
Okay.
space-time?
I get that now. What is it? Oh,
Now, I've heard this before recently. People are telling me that this space-time is all around me, but I have not yet seen a sample of it, or anyone told me what color it is, or how much it weighs, or if it's a tweed fabric, or if it's more like I don't know, cotton. What kind of fabric are we talking about here?
I don't know. I don't exactly know like the real world analogy for it. You know what the theory of space of the fabric is? There's a theory that Neil deGrasse Tyson said. Obviously we can all trust him and we all love him. He said there's a theory that it's just a bunch of tiny wormholes.
Yeah.
Right. So that has it carries as much water as a fabric.
Can we have wormholes on a flat Earth?
Yes.
Free.
I just thought that was interesting, so I just wanted to mention it.
Earth wormholes?
Earth what? No, just wormholes.
You guys don't know the history of the term flat Earth, huh? It was originally coined by a glober trying to henpeck somebody into a position that, well, they just didn't believe in the heliocult model. That was it, right? Just didn't want to join the religion. So you got to label your opponent the disbeliever, but you have to name him to attack him, right? So you can't just attack somebody that goes, you're crazy. Can't prove that.
Yeah.
It was 1915, I think, when that was coined. It's just people that are from Earth, basically Earth people, Earthers, whatever you can call it. It's just Earth. I mean, if you don't have a globe, right? If there's no bending and warping of anything, like the distance between objects or a concept of time, which is a measure in forward. I mean, what do you got?
Like wormholes.
Right, but that's in the weeds, man. Like, how does that explain anything?
I should have left the word worm out. I should have just said a lot of holes. You might have understood what I was saying there.
Oh, puns, yes, puns.
Good.
Oh, God help me. It's not good for my.
What did it tell with?
I'm in Minecraft and being beaten to death. Please tell me that worked. Oh my God!
Yes.
No, I'm keep being cobwebs. No. Oh, that's tragic.
It seems to be some kind of prank prayer or something.
No,
that is kind of a.
I genuinely get that scared when I'm playing Minecraft.
It is kind of amazing, though, right? We understand what holds something to something that we don't have proof of, but then we can't do the thing that we say exists, even in a small scale. Like, that blows my mind, because I have a construction background, and I'm a tinkerer. I like building stuff.
Yeah.
So if I can have it big and not small, that really doesn't make any sense to me, because I got a big engine and a small engine. Got a big pump and a small pump. Like,
Yeah.
how do you have a big thing, but then you understand, right, the concept and how it works, the amount of things that go together. It's not just mass that causes what you guys are saying is real. There's more you haven't even touched.
It is. It's the amount. It's the presence of like how much mass you cram into one place, and then the more mass you cram into one place, the stronger the gravity is. You can't
Hang on, hang on, hang on, hang
an
on.
incredibly dense object to measure to do a reasonable warpage experiment on Earth.
Okay,
to see, like,
so
warp
so you're
length.
telling me there's no magnetic field then? Okay, cool. Whew. Earth
Well, I
doesn't
mean,
have an electromagnetic field or a magnetic
Yes.
field? Like,
what does that have to do with gravity?
what does it have to do? That is a very good question, finally. Actually has a lot if you look at it. Because without it, most of what you know wouldn't exist.
Without the field, what happened to that guy? Without, wait, what
You
does that have
think
to
the
do with gravity?
device you
What does that
you
have to do
think
with
the
gravity?
device you're using doesn't have a field?
Yeah, but I know magnetic fields are incredibly useful, but like, what does that have to do with gravity specifically?
Some people say it's the cause of why things appear to.
Well, you have static, what I call static cling, which others call a dielectric plane. It's all about the same.
It's all to do with energy, more or less energy, potential energy. The actual environment of our system sees contain a lot of potential energy, discharges, static discharges, lightning, and so on. Other electromagnetic phenomena high up in the sky as well. So some people suggest that the way that our reality operates is primarily electromagnetic.
Interesting.
I'm not saying that's what I believe or whatever. I'm just saying that's what some people suggest.
Well, I mean,
But it is
it's
interesting.
a big proponent here. My compass would stop working. So it's like either it is a factor or it isn't.
But obviously exists. Now,
I mean,
I
yes,
don't
well,
think anybody would disagree that it obviously exists. We've all held compasses, right? It's just what it
yeah.
does.
Hold on, it still hasn't been related to gravity, either that or I missed it.
No, it's not, because there really is no connection as far as we can test that magnetism of the Earth has anything to do with the vector of, whether things go up or down, as far as we can
Oh,
tell.
oh, okay. I thought one of you was claiming that it was. Okay, never mind.
No.
My bad.
Well, everybody's in a different spot, I guess. So I have a different understanding of things than maybe somebody else, or maybe we say them differently. It is what it is.
Okay. But yeah, no, I get why you don't get it because you've been working your whole life with like stuff
Huh?
that works. Like, no, I'm talking like, you know how you said like, oh, you have big pump, small pump, big engine, small engine, like it all works. And if you have an idea of like, oh, why something works, you should be able to do that on like pretty much any scale, or like at least on a smaller scale.
Well, I can make lightning in a box. I can make storm clouds. Hell, I can even make a storm in a decent sized box.
What
Yeah,
are you
because
trying to make that we can't make?
gravity.
Okay, so what causes gravity? We've been
And
through this. You need an awful lot of mass to
yeah,
distort the space-time.
you
If we're
know,
to believe that story, right? So
okay,
within that story, basketball doesn't have enough mass.
yeah,
It's like saying we need an awful lot of energy, right? An awful lot of electromagnetic energy to create an electromagnetic field as powerful as the Earth. We don't have the amount of energy that's within the core. I'm just throwing shit out there, right? But it's the
okay,
fact that within this idea of gravity, they can't create the amount of mass. That's why they need things that are really big. We call those things like moons and planets and shit. Or they have to be outside of any other gravitational influence. So a small object, even though it has a relatively small mass, can,
yeah,
on a local small scale, attract or distort a straight line of another object that has got mass in its deformed space-time fabric field. So you have to
yeah.
remove away from the Earth. So in their idea, to answer this question, I've got to make a planet in space or take a small amount of mass away from the Earth and gravity. This is why they like to tell stories about going up in the sky.
Right, because when you can't explain something, you fly away.
Yeah, you tell stories of lands, mythological. There are talking lions. So yeah, it's all theoretical, right? The concepts exist, the mathematics exist because we say that. What should we call it? We call it mass. If there's a lot of it, there's a lot of energy there. So energy, the energy is there to store the space-time fabric, which we can kind of say causes this phenomena to happen. It doesn't actually cause it, but I tell you what, we can make a good mathematical that kind of explain the day away. That's nice. Mathematical concepts are great like that. We can get lost in them, as Tesla was kind of pointing out 150 years ago.
Right, but space isn't a mathematical concept. So in order for this ideology of Einstein to even be accurate, it would have to be something that's bendable. But like, okay, I'm sitting here and there's another chair. It's 3 feet away. How do I bend the space between me and the chair without having to move?
You create more mass somehow,
Black hole.
Well,
which is even
hold
more
on.
mass.
I'm just trying to bend the space. It's the distance. So
Yeah,
I'm trying
yeah.
to
It's
bend the distance to make it
what
closer. How
bends?
do I
Sorry,
do that
Dave.
with?
Dave, it's like you're
Oh,
almost there. What
I don't
bends
think
space?
you can't do that with gravity. That's like
Hold on,
wormhole
dude, please. What
theory.
bends space in their ideology, right? What bends it?
Mass.
Yeah, cool. So when you're in your chair and your friend
Mm.
is in your chair, how do you distort the space between you so you fall towards them? Well, you need more mass
Or
in their
they
idea.
start eating.
Yeah. Time to order from Domino's, right?
Yes. Technically, actually, you could just hold the pizza and that would be the same thing. Or wrap it around yourself. Oh no.
Is it mass or density, or is it both?
It's the amount of mass in one space, so like both density, really mostly density.
Is it
Well,
about
see,
both?
this is why mass, as far as I'm concerned, is undefined. Because what is mass? Is it weight? Because weight is weight. What is mass?
Yeah. Weight is the effect of gravity on mass. Mass is just physical matter.
Whoa. Physical matter. So physical matter attracts physical matter.
Yes, yeah, honestly, pretty much.
Okay. And how has anybody ever proven this?
My favorite term, mathematical models.
Okay, so it's only conceptual then. It doesn't exist in reality.
The mathematical models are proven by reality. Like we can cross-reference them with like,
No, that would be circular reasoning. That would be affirming the consequence.
Could you, for
Really?
example, get enough mass
Oh, yeah,
of gas where the mass of the gas would stop the expansion of the gas?
there would have to be a point in the middle of the gas, like in the middle of that like cloud, that's so dense that yeah, it does pull all of it.
Yes, it is the problem, right? It's going to need, the only way that you can even talk about density is with volume, right? And to have a volume of
Yes.
gas, that you're going to need a density and you're going to need a container. So my question is along those lines, right? Where you need a container to stop the gas expansion, can you have theoretically an amount of gas which will stop entropy taking place?
What's entropy again?
Entropy, that in simple terms, the spreading out of energy and stuff that holds energy, like gas.
Okay.
So gas always wants to expand, right? If
Yes.
there's an available volume for the gas to expand, it will over time expand into that. The only restriction is the space. The container. If you've got an infinite space and you've got some gas inside a container to the infinite space, the gas is going to spread out.
And eventually, over whatever period of time, it will spread out into all of that space, eventually. So is there an amount of gas that you could have in a space that when I open the container that's surrounding the gas will not expand into that available space because the amount of mass that's in the gas?
You couldn't just release the gas because that would be very unlikely that it just suddenly becomes so dense. Or you could place like not the gas itself, not really.
No.
It'd be extremely hard.
Yeah, because the gas has got energy, which gives the gas going. It has constant collision with other gas molecules because that's all that there are in a hypothetical environment is all large space. So because of those physical collisions, the kinetic energy is going to make a consequence the gas spread out. No amount of gas is going to stop entropy taking place. It's thermodynamic law, dude.
Yeah.
So Jupiter, an uncontained ball of gas in the vacuum. That can't be real.
Oh my god, I studied this.
Well,
What's Jupiter's core?
that explanation of what Jupiter is definitely can't be real, because then Spaceballs would be real, right? Everything would have to have its own container, and every other thing would have to have a separation of containers.
Mm-hmm. To have balls of gas in the vacuum, those balls must be physical surrounding the gas. Vacuum. Without the container, the gas is going to spread out. Doesn't matter the amount of gas that you've got, that's just going to make the problem worse.
Hey, what's up, guys?
Stop.
Standards.
I would like to join the conversation if that's possible.
Yes,
Oh my
please.
God, your voice is deep.
Nope, that's wrong. Wrong.
What wrong?
You wouldn't have to have
That
separate
is
containers.
the wrong voice coming out of the right microphone.
Sorry, what?
Sounds like a voice
Seriously.
changer.
No, this is my
Seriously,
voice.
though, you
Oh, this
wouldn't
is
have to
my
have separate containers.
100.
All right, cool story, Beans. I'm trying to make a point, Beans. I don't need 500 people to talk about my voice, all right?
Are you guys talking about me, man?
You don't? All right, cool.
Yeah.
Anyway,
But,
you don't need
why
separate
your voice?
containers. Oh, fuck, dude. All right, Smiley. Chose poorly. All right, so you don't need separate containers.
Ah, that's S.
Period.
Okay, hold on.
You could,
He's going to say
it
it
could be
again. You don't need...
accomplished.
Go on.
All right, listen, I'm going to make my point to completion. Thank you, everyone.
I know.
All you need is something to stop the expansion of the gas. That could be a liquid. There could be a liquid between all of it, and each pocket of gas is contained within the liquid. So that wouldn't be separate containers. It would be one.
The gases would be contained within the physical liquid.
Right.
Yeah.
Now, that's not to say you couldn't use language to say, oh, that's kind of like separate containers, but, there's connotations and denotations. So when people imagine separate containers, when you say that just casually, they're going to think, oh, each object has to be encased with some other object, like a dome or a glass ball or whatever. But that's not true.
You bring up like a bubble, right?
Yeah.
Yeah, cool. Yeah, you're right.
A bubble is contained gas inside another medium.
Yep, 100%.
Right?
Yep.
Now, you could argue then, well, all the bubbles must be within the medium that medium itself is contained, sure, but you don't need distinct separate containers for each pocket of gas. Okay, make sense?
Yeah.
No, because it's not really. No. I mean, the way you were defining it there, AI, it would just be that each different material is a container in reference to another material that's different. So they would just that's just how you would define a container then.
Yeah. Within, I'll bring this up quickly. Within PV equals nRT, we solve for pressure, which is force over area. The area is just described as a physical boundary for gas to press against. So that just invokes some kind of physicality. That can be a steel wall, or as AI is pointing out, liquid, still physical.
Right, now that also bears on this point, which is one of the arguments that I think made a list about bad arguments, which is gas pressure requires a container, therefore the Earth can't be a globe. Now, that's not a good argument at all, because you can have globes inside containers.
Yeah. Okay, so you can't have gas pressure without a container, so therefore giant gas planets can't be spheres?
Oh yeah, you're
Right.
not going to be able to get away with that. You cannot have if you can't have gas pressure without a container. Earth is flat. How's that? Gotcha.
How does that?
Gotcha,
How does that
bitch.
hurt? Right, but I could show you. I could show
He
you an
bumped me.
object of any permutation of shape. Well, it's easy. I could just show you a container with another object inside it, and then I could just have three different shapes: one a ball, one a cube, and one like a, let's just say, a flat cooking pan. There you go. I now have three different shapes, which the container doesn't change the shape of the object inside it.
Yeah, but then the Globers are going to have to start conceding that they've been lied to because they're not being told that they have a container around the globe, and they won't do that.
Well, wouldn't it be more pragmatic for them on their side to just say that space isn't a vacuum; it's actually just a hyperliquid? So not
It would.
not not a
They could not
super
go
not
on.
a superfluid like some people have postulated in the past, but they'll make it even fancier, like a hyperliquid. So the liquid is actually transdimensional and space-time conventional. And all these weird words they'll come up with, and it'll work mathematically.
Yeah, they probably
I
will do
like that.
something
I
like that.
laughed. That was funny.
We still flat smacking bean toasty. Bean toasty is like day 3 for you or something.
4, I think.
Day
Might be.
4. That's cool. Well, when someone's been here for a few days, I like to ask them to summarize some things they've learned since they've been here. Could you tell us a couple of things or a couple of points that we've made that you've learned since you've been listening?
Also,
Yes.
hold on before you do that. I'd like to point out that rotations have started because it's the new year. So all interns are now rotating and CDPs are rotating. So he might be on rotation. That's why he's been here 4 days. Anyway, go ahead.
I have no idea what that means.
It's okay. Yoder does.
Flat earthers aren't lunatics, basically. They're not, honestly, not completely lunatics. Most people probably still think you're lunatics from back in like space disc days when everyone
What have you learned, sir?
when everyone thought, oh yeah, my bad tangent. So you guys only observe. You guys only say what you observe, or you guys at least, not everybody. You guys only say what you observe, and
Right. Wow.
if you can't have absolute proof, not just like, oh, this is probably or this is most likely at 99%. No, if you can't like see it, like physically see it with your own eyes, the level of proof, you guys don't.
Okay,
follow
so
that.
we hold to empirical evidence, you're saying.
Yeah.
And does that, would you say that's a good standard, empirical evidence? Isn't that good?
Yeah, but I think also like if something is 99% probable certainty and you have like good amounts of proof for something and like math that checks out, I think that also is good.
So then the Earth is flat. If you got 99.9% Earth is flat, then it's flat, isn't it?
Well, empiricism is the basis of science, and you're saying that you've learned that we go with empiricism. So, yeah, we go with science.
All right.
What else have you learned?
What else have I learned? Just like random oddballs of like, no, because again, you guys wouldn't say that.
What's like? How about like what's an argument? Like best proof of the globe or best proof of the flat Earth?
Oh, your best proof of the flat Earth is that you physically have never measured a curve.
Not
We
just
measure
us.
it flat.
Anyone.
In other words, we measure it flat, right?
Yeah, our argument isn't just that we've never measured curve, it's that no one ever has, right?
Yes.
So
Remember
two
I said that to you
choices.
the other day? Sorry.
That's fine.
Sorry, go on, Jenna.
Yeah.
No, I just wanted to be clear, right? So we don't measure curvature. So if the line isn't curved, we measure it what?
Flat.
Cool, awesome. So we measure it flat. Sorry to interrupt. Carry on.
No, I was just gonna say, because the other day I made that point to you. I said, "Well, we're pointing out that no one's ever measured curve," and you were like, "Well, I'm sure someone has." Did you ever go and have a look and find someone who had?
No, I was busy playing Minecraft.
Okay. Well, don't waste your time. No one has.
What should I search up? No, because there's gonna be a paper where someone claims to have. I wanted to bring that.
Yeah. Oh, don't get me wrong. I mean, I'm sure a load of people claim, or people claim that other people have, but no one actually has, is the point. So yeah, people might claim it, but people can claim all kinds of shit. It's about what they've actually, what can be verified and repeated.
Oh, yeah.
All right, so
It
we're
also-
empiricists. There's no curve. What about the globe? So since you've been here, you've heard a bunch of globe believers come in and talk to us. What's the best globe argument that you've heard since you've been here?
Actually, I can't remember any of them.
Oh,
I
that's
can't remember
interesting.
any of them to the point where I don't think a glober has come in while I am in.
Yeah, that's right, isn't it? The globers actually don't have an argument. It's even worth remembering. Crazy, huh?
I guess.
Think they'd have something. Oh, well, good for you, Beans. Sounds like you're going to figure this out. Good luck.
Or chance. Da, da,
So what are you
Have
thinking
you,
now? What stage are you at? Like, what stage in your research are you at? Are you looking for curve? Are you trying to debunk flat Earth? What are you trying to do?
Oh no, I'm not researching in my spare time. I come here to listen to you guys, and that is basically it. Because lucky I have better things to do, like play games.
Clearly not.
Honestly, I'm on my break right now after studying for like uni in Mosque. So I'm just like kind of enjoying myself, honestly.
Yeah, that's fine. That's fine. But I mean, you're coming here because you're interested in the conversation. You obviously
Yeah.
find discussion about the nature of reality interesting. So you must have like some idea of where you sit. I mean, are you still 100% believing you live on a globe or what?
Like 80.
80%. All right.
Like 80,
We
which is
can work with 80.
actually what?
We can work with 80.
Yeah, I guess you can work with 80.
Yeah, he's only 6 months away.
Okay.
What piece of evidence would you say is making up the largest percentage of that 80% confidence? Is
The
there
massive, like
something?
the massive model that explains everything.
A massive model that explains everything?
And I'm
Oh, well, this
saying
is a good
model
one
as in
then.
like as in you could like build the solar system. Like I mean like that type of model.
What kind? Well,
Uh-oh.
what kind? Do you mean a kind of model that doesn't actually exist in reality, that's not been made, or do you think it has been made?
Yeah, it has been made. Like that. Like that's what I'm saying. You could
Okay,
build the
okay.
solar system.
Could you post the link to that model in the chat?
Do you want me to like buy you a
Like
solar
the
system?
globe model, whichever the model is that you're saying gives you the most confidence in the globe. Could you post that in the chat?
Okay, well, there's not gonna be one that covers everything. I'd have to like post multiple, but yeah.
Oh, wait. So, right. So you don't
No.
have a model. You've got loads of different models. Is that what you're saying?
Oh no. Simply because no one would have made like one massive thing that I can just send you. Like, oh, it's
Why?
like
It should be
But it would
simple.
have to. But you're saying. But they would have. The model would have to explain everything to be an accurate description of a model of the Earth that explains
Yeah, no.
everything, right?
You could make the model, but like you could make the solar system, and then you could like make the Earth. Like you would have to use a program to do this, but like you could make.
Okay,
the
so
solar
help me
system, make the
understand
Earth.
what it is then, because you're saying the thing that makes you most confident is a model, but now you're saying it's a whole bunch of different models. What models are you talking about?
So yeah, so you could like you could make the solar system and like
A
describe that
solar
like
system model. What kind of model do you mean? Like a computer one, like an image, or like
yeah.
a physical model, or what?
You could do the solar system on all three, but to make this like massive complete model that would show everything, you would need to use a program. like because no one's making this in
Okay,
real
well,
life. It would take
which one did
too much
you
effort.
see that gave you this confidence in in the realness of it? Which one are you talking about? Or are you kind of just
I don't think
thinking
I'm
that there
explaining
is one
myself.
and you've never really actually seen it?
I don't think I'm explaining myself well enough.
Okay, well, this might come as another shock to you, Bean, but this model that you think exists somewhere that is good evidence for a globe does not exist.
Hold on, let me just at least do something to illustrate what I'm saying.
Just like that
So
curve,
what
Bean.
happened, Bean, is that they've told you that the Earth is a globe, and that's what reality is for so long that people start to think that things only make sense in respect to the globe. But you just feel that way right now. That's not something you have proof of.
Da, 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 da.
It's just like a side effect. They just tell it to you for so long that everybody says no. Reality only makes sense if the Earth's a globe. And then you ask them to point to reality, and they're like, well, I don't know where it is.
Look at your
Okay, so
predicament now,
here's
right? You're
here's a good.
80% sure because of a model that it explains. That's your predicament.
Hold on, I got the link. It's actually a game, so that works. Where the hell is the share link?
Like Universal Sandbox or something.
Precisely. Oh, I
Okay.
hear you chuckling. What is? Yeah.
So if you just, I mean, you sound like a smart guy. I'm not joking. Like, it sounds like you can understand that looking at Universal Sandbox wouldn't actually tell you in any way that that is what reality is. Like, you could make a sandbox imagining a totally different setup, but with the same observations mathematically. You know what I mean? Like, you could have the things being larger and further away, or closer and smaller. And from your
Yeah.
perspective, for what you're observing, it would all look the same. So
Actually,
how would that representation specifically tell you that's the correct representation just by the representation? And in that case, is it justified that that would be a main convincing point for it in your overall 80%?
Yes. I want to like. Okay, so for me, this works because what is it? So I can make this. I can like go. I'm not gonna like not universe sandboxes and like throwing the Earth at Mars, but like just like you load into universe sandbox and there's the solar system. I could like look at Earth and look at the weather, and I could tell you how it works, and I could go to a star in the distance and tell you how that works, and then
Yeah, but someone else could build another model that explains all this stuff, and it would have different distances and sizes, but mathematically it could all work out the same in terms of the observations of the sun, moon, and stars. So how would you know which one's real?
The ratio would be the same.
using theories other than gravity and like nuclear fusion for stars. You're saying like that?
I don't know how that would tell you whether the simulation that you're looking at or the model that you're looking at is correct, because again, you would just be speculating on those mechanisms, saying, well, the reason that the sun's moving like this is because of gravity. But again, that's just an explanation you've given to it. It's not something that is really telling you the truth of it.
A cyclone, I could provide an example. On the internet, you can Google this. People have created, out of the math, not a solar system, but a lunar-centric, call it solar system, where the moon that we observe is actually stationary. The Earth orbits it, and all the planets that you'd find in a solar system are also in orbit around it. And this would be indistinguishable from what we observe in the night sky.
Yeah, and that's a great kind of example as to what actually happened with the Copernican revolution, with the Copernican system, where he essentially took the observations that have always existed of the sun moving and said, well, what would it be mathematically if the sun wasn't moving and the Earth was the thing moving? And you can just backwards engineer that mathematics and say, well, look, the math works out. but that doesn't mean it's true. Do you understand?
Yes. Okay, this is the counter argument to my argument. Send the moon. Send the moon model. If there's a link to it.
Send in the moon model.
Yes.
Same phenomena can still take place underneath a stationary Earth, and the phenomena are just taking place in the sky. The Earth doesn't have to be in motion to observe things go by. Should really become a poet.
Yeah, and funnily enough, this is what all those big astronomers throughout history have said themselves. They've said, well, this is essentially just a philosophical position that we're the thing moving around the sun rather than the sun moving around us, because you could justify both positions with the same observation. Like, they actually say this. So just having a model that says it's one way wouldn't prove it any more than us saying, well, the Earth is flat because if you imagine the Earth's flat and the sun's moving, therefore the Earth's flat. Right? That's not proof. I mean, you could say it could work that way, but you're not actually interrogating physical reality to prove that it is the case. That's why we go after curvature and motion and all this stuff, yeah, rather than just models, which, like we've said, you could come up with a model to explain it in a million different ways, I'm sure, if you thought long enough about it.
Okay.
I think up until now, right, up until recently, we all have this, right? We only think there's one way to explain reality. The Earth being a sphere and the sun at the center, blah, blah, blah. We think this is the only option. And any other idea has been really far removed from any like logical thought process that we might be able to entertain, because this is the state of affairs. So you've never been allowed to think of any alternatives, dude. Same with all of us, right? We still struggle with the same things that you're struggling with right now. Well, if the Earth isn't this, then what is it then? How do we explain these things? Primarily the things that you're trying to explain, the things in the sky. But ultimately, you're coming across the same questions that we've all got. That's why we're sitting here trying to like let you know that we don't know. The best model that we've got is the Earth is flat and stationary underneath the sky. That's about it.
Yeah, that's a good point. It's like we've been intellectually boxed in when we think about the Earth and our reality by this globe story that we're given as a young person. So we find it difficult to take ourselves out of that and imagine other possibilities, even though there are countless possibilities. And it's something like that Crit says, which is through history, let's say we've went through 1,000 models and we've arrived at the globe at 1,000 and everyone's like, great, this globe model number 1,000 is the correct one. We're just saying, no, it's still not correct. We're on to like 1,001. So we're not actually that far apart. You see?
Excuse me, my dad was talking to me. I don't know if you want to repeat that.
I was just adding to Jedi's point that if you look through history, it's basically been the case that we've had like 1,000 models for what the Earth is and what the sun and moon and stars are, what reality is basically. You've landed on 1,000 like we all had. We're just now saying no, that's number 1,000 isn't correct either. It's something else. So we're not really that far away. We've just rejected one more model.
Do you have like a link to that moon explanation? Because that's actually, I really want to see that.
I'm driving. I
Yeah,
don't have a link handy,
so.
but I just Google it.
Fair enough. Lunar-centric model. That seems easy. Lunar-centric model.
And see, I think speculating on the nature of reality is a very healthy and human thing to do. And I think it's wild that people basically have to come to a flat Earth chat to have that kind of philosophical freedom of expression. You might be the type that's done this before anyway, but I think most people haven't. It takes for them to come here to then be like, huh, what if the moon was at the center of this whole thing? You know? Because, yeah,
God, I
most
hate.
people just take it for granted. It's a globe.
Ugh, my nose.
Well, we know it's not a globe. So you got any questions at this point, Bean? Or any other new people or globe believers in the chat who want to ask the question? Feel free.
Please tell me
Yeah,
there's
while you're
another
waiting,
globe.
bro, in the heliocentric model, the sun isn't even the center of the solar system.
Excuse you,
Things
what?
things don't things don't revolve around the sun. In fact, they revolve around this address I'm going to post. I'm going to post
Sorry,
an
what?
address in the chat. I'm posting an address in the chat.
If you say like stupid lane or something, I'm gonna
Search up that address and it'll give you the answer.
Is it the Barry Center or something?
Exactly, it's the Barry Center.
Hey, that's 2 for 2 today.
What?
Yeah, you didn't know that? Now you know.
Yeah. I'm so confused.
Do you know what the Barry Center is?
No.
Okay, so it's, if I'm correct, AI, it's the sun is also moving around itself and being disturbed by other planetary activity, mainly Jupiter. It's like not completely the center of the sun. I think it's the same with the relationship between the Earth and the Moon within our idea. It's not actually the center of the mass of the sun that's the center of the universe. Oh, sorry, the center of the
Okay.
solar system, not universe, solar system. I think that's right,
Okay.
AI. Please
Right.
correct me if I'm wrong.
So you're telling me the center of orbit, is that correct to say? Just so I understand. The center of orbit of the solar system is the Barry Center.
Yeah. Whoever Barry is.
You're joking. No, you're joking, because then how would the planets would then rotate around Earth?
The planets rotate around Earth. What?
No. If the Barry Center was the center of orbit or mass of gravity.
Well, they say it's like you put a bowling ball on a bed sheet and you spin them all around, and they're
Oh.
eventually going to fall into this big well. That's kind of what they're saying, right?
Yes.
Isn't that crazy? Like, people come in here calling us crazy for pointing out that observably and everything we experience is a flat, motionless Earth. Meanwhile, they're claiming that reality is a bunch of bowling balls thrown around a bed sheet with no evidence whatsoever.
Analogously.
Yeah, with no evidence whatsoever for any of that. Never even seen it in principle occurring on a smaller scale, other than bowling sheets on a bed sheet or bowling balls on a bed sheet.
I mean,
I think that's funny.
we have observed gravitational waves.
You haven't
No,
done
you've not.
shit, son.
You've
Related.
not observed
Yeah, really.
gravitational waves.
You haven't even come close to doing shit. Besides taking a shit.
Section. No, so we did like what was it? The detector, the thing that detected them, moved like half of the width of a proton.
Yeah, the super
Prove it.
Globerg detector 9000. It's
Yeah, prove
totally
it.
real. Trust CNN, bros.
I want to see what a proton looks like and how you measured that to get how far that moved.
I think it was 1/10,000th the width of a proton.
Good lord. Yeah,
Yeah,
I
so
thought you
it's
guys
basically
would like.
made up.
Lucky I just trusted that they have like precise machine.
Gravitational waves.
Predicted that
Bowling balls on bed sheets. Just remind yourself, whenever they're trying to tell you anything fancy, they're basically claiming that you're on a giant bowling ball flying around a bed sheet.
Analogously, yes.
Yeah, it's ludicrous. What on earth in reality have you ever experienced that would make you think that's even a possibility?
I mean, the universe has no reason to make sense to you, so like, just because it's weird does not mean
It
it's
doesn't.
not real.
Well, yeah, I mean, fair enough. I mean, you could say it could be anything, but in that case, you've got billions of possibilities, and you've just landed on this totally random one with no supporting evidence. And apparently, it's anathema to society to even question it.
Oh man, you know what's funny, brother? You just said the universe is not responsible in any way, shape, or form to make sense to you. Okay, let's say that's true. Did you know that guys in the evolutionary biology, psychology, and cosmology fields have decided that not only is the universe not responsible to make sense, but your faculties that you possess because they evolved for survivability, not truth, can't even be trusted to arbitrate truth. So even if the universe could make sense, you have no reason to trust your faculties to make sense of it. So basically, we're all just living in one big retard land. Well, that's weird. That's weird.
Yeah, it's also weird that people come in here asking for models that make sense.
Okay, that's fair enough.
Could you imagine if we were coming out saying, "Hey, yeah, look, it's like this bed sheet, and we're this rock on this bed sheet"? They would laugh.
I mean, if you just said that, then yeah, but if you had like supporting math that everyone else,
Yeah, we can give you
they,
the math for the rock on the bed sheet. That's easy. But so what? So then it would have credibility.
yeah, because math is like,
See, this is the
it's math.
problem. You think
I
just
don't need an
because
analogy.
but math is just a language. We've got the math for how Superman flies. You don't believe Superman flies because there's math supporting it. You understand that's not real. So just because they might have math for the bowling balls flying around the bed sheet, and we could come up with some math for a piece of rock on a bed sheet, doesn't give either of them inherent credibility.
Yeah, the bed sheet actually proves Earth is flat. In case you didn't know, I'll explain.
Is that?
Yeah, that's the only bit that would have
Yes.
credibility. At least we have a flat surface to match the bed sheet.
Well, it's more practical than that. So check us out, brother. So when they do the bed sheet that they stretch over this big tub, and then they put the ball in the center, and then they put other balls, and they go towards the bigger ball. There's one explicit reason why they go towards the bigger ball only, and that is because when they put the ball on the bed sheet, they create an inclined plane. And everybody knows that when you place a ball on an inclined plane, it rolls down the plane, down, perpendicular to horizontal, which is the orientation of the Earth. Therefore, this demonstration proves the Earth is flat.
Wait, do that again slowly.
Right? You put the ball on the bed sheet.
Yes.
It makes the bed sheet deform, and it creates a diagonal conical shape. That's called an incline.
Yeah.
Okay, when you create an incline and you put a ball on the top of the incline, it rolls down, correct?
Okay, yes.
Right. So what they're demonstrating, they're only demonstrating one thing in that demonstration, and that is what we all already know. Things roll downhill. No duh. That's been our experience our entire lives. When we drop something, it falls down. When we put something at the top of the hill, it rolls down. So all they're just doing is demonstrating our common experience. They haven't shown us anything new at all. They've just proven what we already all know. Things go down. And down is perpendicular to horizontal, and horizontal is the attitudinal orientation of the Earth. Therefore, the Earth is flat.
Okay, I think you are so like I'm saying this. It sounds kind of. I was gonna say like I think you're so sold on the idea of the flat Earth that you're biasing this towards
Dude,
proving the flat Earth.
No, brother, pay attention. Real simple.
How does that prove the flat Earth? Yeah,
it's simple, dude.
Things roll downhill.
Things roll down. Things roll down. Down is a particular direction, perpendicular to horizontal. Okay. Horizontal is the attitudinal orientation of the surface of the Earth at all places. All things roll down everywhere you go. All things fall down everywhere you go. There's no place on the surface of the Earth where that doesn't happen.
Oh, right.
So if down is ubiquitous across the entire surface of the entire known territory, and it's perpendicular to horizontal,
right,
then that means the surface is horizontal across the entire known territory.
Okay, okay, I get it.
Now check this out, friend. A
Yes.
glober will say, no, you don't understand. Things don't fall down. They fall in to a giant ball. Okay, now you have a claim on the table. That's not commonly experienced. I experience down and horizontal and perpendicular,
Okay.
which is vertical everywhere I go. No one has experienced inwards and outwards to the earth. Nobody, not you, not your mother, not your great great grandmother, and not your kids 10 generations from now. Nobody ever has, nobody ever will.
Okay.
Yeah, so up and down is flat Earth. You saying up and down? You're talking about horizontal. That's flat. Glober should have to be saying in and out, right?
Yeah, we only say up and down because that's like the human level. If we said in and out, we'd have to
'Cause
like.
that's reality. Because that's reality.
Oh, yeah. Hold on, real quick, Cyclone. Yeah, brother, if you say in and out, you have to prove it. You have to prove it.
Oh no, I wasn't gonna say prove it. I was just being like.
No, you have to prove it. No, friend, you don't understand. The common
Okay.
experience is up and down. We
Yeah,
all
okay.
experience up and down. We all experience horizontal. We all experience that they're perpendicular to each other. Nowhere
Yeah.
do we experience that they're radial to each other. The radialness of them, which would create ins and outs towards the center of Earth, which isn't even true either, but towards the center of Earth. No one's proven that, dude. Nobody. All as they've done is they've shown us down and then told us a story about how it's in and out. That's why they don't use the terms in and out, because if they use the terms in and out all the time, people would very quickly catch on that that's not what they experience. So quit hijacking our terms and get your own terms and be honest with your fake identity of these terms, bro.
Okay.
Now, what have you learned today, Bean?
Loki, I'm gonna need to be quizzed because like you guys know, like remembering facts off the top of your head is kind of difficult. Being quizzed is easy to
He
recall.
just told you. He just told you in order for your world view to be true, his has to be true. And you know it.
Okay.
But yours can't be true. So yours can't be true.
Say that again. I'm bad.
He just adequately explained to you in order for your
Yes.
worldview to be true that things fall down, then
Yes.
his worldview has to be true, where down is perpendicular to horizontal, which means that your worldview is not true.
I feel like that's a messed up version of circular reasoning. You assume like
All
you're
right, well,
assuming
you can
A.
come back to that. Give me a
You're
second, because I'm
okay.
going to head off. I'm going to head off in a minute. But just
Okay.
on the bed sheet ball analogy, I mean, if you're swayed by that, do you not think it's wild that that's basically what they're telling you your situation is? You're on one of these balls flying around a bed sheet. And, you know, when you see those demonstrations, what the logical conclusion to that, the physical conclusion to that whole thing is that within a few seconds, all the balls just crash into each other in the middle. So by logical extension, that's what they're telling you is your situation. You're on a bunch of balls flying towards each other down some gravity well. Right? You think that's true?
Yes, I do think that's true.
Well, do you not think it's wild that they've got you to believe that whole story? And when we ask what evidence is there for any of that, there's like nothing at all. Like models, ideas.
Oh, I had a thought, I lost it.
You know, because your experience in reality, what part of that experience tells you anything about that scenario that they're painting? Like, what physically are you observing or experiencing that would give you the faintest impression that that story is true? Like, name one thing.
I need to lock in. I keep getting distracted.
Well, if you can't name one thing, just say I can't name one thing, and that's fine.
No, I don't want to say repeat that for like the third time, but I generally just keep getting distracted.
Right. Name one experience you have in physical reality that would tell you that this analogy of you flying around a bed sheet as a bowling ball would be remotely true or give you the faintest impression of it being true.
Oh, right. Like explanations from class, from people who studied this.
No, like an experience in reality that you
Oh,
have.
experience none, because again, gravity
None.
does not like operate on a human scale. You
Right.
need a lot of
So
mass.
none. So there's no experience in your reality
No.
that speaks to this analogy at all.
No.
Right. Well, there you go. Think about that. You should really think about that. Anyway, good chats, guys. I'm going to dip off, but good to hear you guys. Keep it cooking.
Peace.
Bye.
Yeah, and I just want to apologize to you, Bean. I should not have
Yeah.
assigned that as your worldview. That's their worldview. You don't, as I've heard so far, don't affirm it. So
From what?
Yep.
you just take on reality as far as I can tell.
I'm so sorry. What? Like what? What don't I affirm?
You don't appear to have a
What?
biased opinion towards the globe.
I mean, gravity I do affirm.
Yeah, but you haven't really even defined it. So I mean, like you know, some people would say like gravity is things falling down. So it's like, oh, there's a flat Earth. The thing doesn't fall down. But,
Hey, what's up, guys? Can I join the conversation?
I mean, I've defined it decently.
Another voice changer. What's up with that?
Yeah, I don't
It's
know.
not a
People,
voice changer. It's using my voice.
I think people do that like to rage bait because like, yeah, they just do it to rage bait basically.
That's fine.
This is my voice, man. I cannot change my voice. You know that.
Josh, please.
Or not to
Not
rage
using
bait
it
just
as
because
your
it's
voice
funny
or
to
not. Stop
themselves.
using it at this particular moment in time. I think just wait your turn, please, sir. Thank you. So you've got a problem with gravity.
No, I don't. I don't.
Do you think that that's good proof that the Earth is a sphere?
Yes.
Okay. Is that because it's a good explanation for why things go down?
Yes.
Okay. So the only problem that you have is because they have an explanation as to why things go down. As long as you believe that the Earth is a sphere and everything's getting to the center of mass, that seems to you. As long as they can explain to you why things go down, then the Earth is more than likely a sphere. But within the idea of the Earth being a sphere, they've got multiple ideas why things relative to your position on the Earth appear to go down. But that's just conceptual mathematics and ideas in the framework of the possibility that the Earth's a sphere, and this is the reason why we need to make things go down, because they do, right? You drop something, it goes down.
Yes.
It's circular reasoning anyway.
Pardon me?
It's circular reasoning. Right? Things go down because things go down. Things go down because the Earth is a ball because things go down. Things go down because things go down. Things go down because the Earth is flat because things go down. It's the exact same argument. What's the difference?
I mean, whatever causes things to go down, it's not going to necessitate the Earth being a sphere underneath it, right? Just because
even his own space-time bedsheet demonstration is appealing to down because it only works when you do it on the Earth and you have an inclined plane, which is just another demonstration of down. So the only thing you can demonstrate ad infinitum is down. None of that demonstrates the shape of the Earth. It just demonstrates that things fall to the Earth, which we all already know. So it's just one big circular reasoning.
Hey, baby, I can bend space-time with my bedsheet.
So, for example, Mr. Beans, when they put the space-time bedsheet demonstration, they put the big ball in the center and they put the other little balls. Why do the balls move at all?
They have momentum, I guess. Or no, because they're drawn by gravity mostly. Yeah, like the
Okay, so notice what you said. You said that in the space-time bedsheet application, the only reason the balls move is because of gravity, and the only thing you're demonstrating in that is down. So you just proved that gravity is just simply down. That's all you said. You just said gravity is down, And the example of gravity being proven is things going down. That's circular reasoning, dude.
Not really. Down is the effect of gravity. Gravity is not down.
Yeah, okay. So the effect of gravity.
Downward motion is the effect of gravity.
Yeah, again, then there's multiple reasons that cause this effect. The phenomenon is still the same. You drop something.
Okay.
It's when you start adding phenomena together that might not even like add. So things go down for you. Things in the sky go round and round. And they're not even the same phenomena, right?
They are like the. Are you talking about orbitals? Like
Yeah,
orbitals only work. Orbitals only work because of gravity,
yeah.
and
Again,
they
because
go
of
round and
gravity.
round.
Yeah, because of
Yeah.
these ideas that the reason why you can drop things is the same reason why things appear to go around and around. And maybe the mechanism is different. Maybe the reason why you drop something is different, and the mechanism makes us. I'm not saying that's true. I'm just saying it might be worth you thinking about. Because ultimately, if you've got a problem with, you prefer the story about gravity, but within this story there's a ball within it, then you might need to try and step out of that framework and try and think outside that box.
Let's think outside the box right now. So, for example, is according to Beans, I'm going to ask you this question: is your idea of whatever gravity is the only thing that can make an object go around another object without physically being connected to it? Is that the only thing that can do that?
From my understanding, yes.
Well, you're wrong. You're
Okay.
wrong, and you know you're wrong because you've seen in your life magnets doing that.
Oh shoot! Yeah.
Yeah, so there's not a single thing that can make something go around another thing. There's actually a few things.
Okay. Okay. Oh, so you could replace gravity with magnetism.
So
and say
I
they're
just very
intrinsically
quickly want to
different.
say, just in case I'm getting that, nobody else is, that's not to say that magnetism is the reason why things go up and down.
Yeah,
That's
no,
only
you
a
just
suggestion of things. And we spoke about this earlier, and I didn't want to get confused again. But
yeah,
yeah,
no, you're making the point that you could replace gravity with this model and like explain it this way.
No,
Is
I'm
that,
just
is that
saying. I'm saying you could have the same apparent phenomenon, something going around something else, and it could have more than one reason why it's doing that. And you could create a model of why it's doing that, and another person
yeah.
could create a model of why it's doing that, and both models explain what's going on, and neither of you have proved anything.
Yeah, that's what I meant. Yeah. Okay.
So, for example, Beans, check this out, bro. Are you aware
Yeah.
of the difference between Newtonian versions of gravity, which, by the way, are named after him against his will because he did not want it named after him? In fact, he wrote, "Do not name this after me because I don't want anybody to think I'm retarded." And then they named it after him after he died to be dicks. But then you had in the future, you had Einsteinian versions of gravity, which we know as the bending and warping of space-time. But do you know the fundamental difference between the two?
What?
It has to do with the space-time bed sheets, bro. So one more time, real quick. Go back to the space-time bed sheets.
Yep, back.
You said that the only reason the balls moved is because you already knew they were going to fall down the hill that was created. So down. But the space-time bendy bed sheet itself didn't actually make the balls fall down at all. That didn't do anything. That didn't do any of the work, right? Because you said it was the gravity that pulled them down. So that means that the bending and warping of the space-time doesn't do any of the work in making an object move towards another object. And that is true. There is no force in the Einsteinian model. So here's the thing, bro.
Yeah.
If you have a Newtonian version of mass attracts mass by virtue of mass alone, so for example, you put a mass in, just imagine an empty space, you put a mass in it, one mass. Now you put another mass in it, and then you
Yes.
press play. The two masses will move towards each other if mass attracts mass by virtue of mass. Now take that, put it on the left side. Now make a new empty space. Put Einsteinian gravity only. Put your mass in the center. Now put another mass over to the right and press play. They won't move. They won't
Okay.
go towards each other. And the reason is because the bending and warping of space-time only changes the direction of motion of something that's already in motion. So it has no cause of first motion.
You gotta say that again.
What I'm saying is that the Einsteinian version has no cause of first motion. If you put two masses next to each other, they won't move. They have to be in motion, passing through a warped space-time, much like a train on a track. If the train isn't traveling down the track, it's not relocated.
Right. Okay.
Right. So this is why they have to trick people with the stupid space-time bedsheet demonstration, because they can only appeal to down, because down is the only thing that has first causal motion that you can experience in any way, shape, or form. And then they try to tell you that the space-time bedsheet idea is the truth, but they're just doing a bait and switch magic trick on you, bro.
Oh, are you at like, what are you at, like 75? You're at 75% right now?
Still 80 actually.
It's got to be at least 79. After he hit you with the inclined plane, the necessary perpendicular relationship between horizontal and vertical, and the magic of bedtime sheets. You're telling me that didn't lower a single point?
Oh no, because I don't understand those arguments yet.
All right, so what's your last hang up then? Like, what is the one thing? There's got to be one thing you're thinking about right now.
No, again,
Come on, you want to say like NASA and satellites and stuff, like, right? Like Earth from space.
Sorry, what?
It's got to be something like NASA, satellites, Earth from space.
No, it's the
Am I
whole
right?
like conclusive model of like the solar system orbits, and like I can go away to a star and explain why that. But then you said I can make a multiple model, and the lunar model exists, and that. Okay.
So one of the things we actually specialize in is we find problems with these prevailing models, these descriptions. So it's almost like how people are paid to find bugs in software and then report them to the software developer. We're not paid for this, but we find bugs with the Globe software and we report it to the world. We've got hundreds of examples of issues. We haven't even talked about a single one yet with you, but
yes.
Yeah, like the fact that you can't predict eclipses with the globe in a heliocentric model.
You can't predict eclipses.
No. There are at least two kinds of eclipses that fail the geometry of the heliocentric model. One of them is the Selenilian lunar eclipse, and the other one includes sunrise and sunset solar eclipses. And this is just the tip of the iceberg, my friend.
I swear I can search up lunar eclipse times right now.
Okay.
Did you know that there's an actual extra day every 4 years and it's not due to a leap year?
Okay, why?
Why? I don't know, but if you were to pick any meteorological station that keeps track of the sunrises and sunsets throughout the year, any single one will do. And pick any single day. I would choose maybe an equinox or a solstice day. Now, what you do is you count the number of times the sun rises and the sun sets from that particular point. So you could even do this with a stick in the ground. You put a stick in the ground, you measure the shadow length and position, and then you count the number of sunrises and sunsets it takes for that shadow to return to that particular spot on the ground.
Yes.
Every 3 years, you'll have 365 sunrises and sunsets. And on the fourth year, you'll have 366.
Yeah, that's because the.
Okay.
That's because.
No, we are taught that there are 365.24 days every year.
25.
24 in a trailing decimal. And it's because of the difference between the sidereal year and the solar year.
Yes.
And this is explained with orbits. However, what you actually observe is not that at all. What you observe are sunrises and sunsets. And you can count them, and you can go through the spreadsheets of any data that you have from any city, any town that keeps track of the meteorological data, and you can count these yourself. And it's a cycle that repeats every 4 years.
You actually have one extra day every 3 years, right?
Yeah,
29.
the 4th. And what's even funnier is that year doesn't line up with the leap year on our calendar. It's off by 2 years.
Oh. Yeah, predict that.
So what, they
Yeah.
just dropped a
Sorry,
day?
so in the if I'm getting this right, I hope I am. In the heliocentric model, all right, they say that it takes an extra little bit of time every year, but actually what's happening is really within that model, the Earth is taking an extra day and rotation every year to complete a cycle.
Yeah. Yeah. So if you go 1 year and you count 365 days, the shadow that was marked by the stick before returns to its same spot. And then on the 4th year, at 365 days, the shadow's not quite where it returns to at that particular point. You have to wait an extra day, and then the shadow returns to that particular point in the ground. And this was actually noticed by the ancients. This is called the tropical year. This is what produces an analemma.
Hold on, this is what produces. What do you mean by?
Well, the
I
tropical
understand.
year, the analemma shows you the furthest extent north and south that the sun wanders in the sky. And you take a picture of it every day and it pops up. But the funny thing is, if you do an analemma, but you do it if you do it for 3 years, and then you do it the 4th year, you need an extra sun in there. Like,
Oh yeah, okay,
yeah.
yeah. You need an extra sun. That makes sense. Okay, but that's still, I don't know, maybe I've walked past this many times, just haven't noticed how interesting it is, but that is really, really interesting.
It's freaking weird. I went through the data myself. I did this once. I heard Antonio Subirats bring this up. He brought it up in one of his long form discussions, and then he brought in a guy from Russia who talked about it. This is like 7 years ago. And then I'm like, nah, that's BS. You got to be kidding me. And the Russian guy was describing the data he was going through just like I described to you. And I'm like, no. So I did the same thing. I went through and I counted. I downloaded the sheets. I exported to a CSV and I started counting in Excel. And sure as shit, like that's exactly what happens.
Yeah, explain that, Bean.
Yeah. But it's kind of in the way that it's described, right? Like if you were to go into any AI and describe it the same way that I described it to you, the AI would be like, it's okay, but really what happens is you got extra, 0.245 days yeah, I'm not joking. And this is due to the sidereal time being different from the solar time. So I don't know. I mean, maybe there's a way to connect it to atomic clocks and precise timekeeping, but even then, like there's a difference between UTC and UT1, which is this is where you get into the equation of time with the sun, accounted for with atomic clocks, that every year or even continuously now, atomic clocks are actually updated according to the sun's position, not the other way around. Did you know that?
Oh, wow, no. Okay.
Yeah,
That's
so they
interesting.
calibrate atomic clocks based off of the sun. Nature is always the true reference, guys, for time and for Earth, because water provides that nice horizontal level.
It's interesting, Bean, right? Again, as we're speaking, the globe Earth doesn't make these predictions. Even like when the sun's going to come up, that gets dealt with, like Yoda just said, the equation of time. That doesn't involve any geometry of a sphere. No sphere here. No prediction made by a ball in space for that one. So you understand that we've been post-dicting eclipses for thousands of years. I say post-dicting, right, because it always does the same thing, right? Over certain periods, the patterns that it produces repeat. So based on what it does before, we can say with a surety what it's going to do again in the future. We've done that for thousands of years. It's called the Saros cycle. NASA used that Saros cycle today. No globe Earth geometry involved there either. So the globe Earth geometry doesn't predict lunar eclipses, solar eclipses, doesn't predict when the sun's going to come up and when it's going to set. So what predictions about the night sky does it make?
Yeah, the beauty of the Saros-cycle is the Saros-cycle being developed by the Chaldeans from 3,000 plus years ago. They were flat earthers and they produced a table of timing and geometry that is so precise that NASA uses it today for their eclipse predictions.
Impressive.
There's a man named Dr. Fred Espenak, Espanak. He wrote a book called, the freaking cycle of eclipses or something, the multi-millennium cycle of eclipses based on the Saros cycle. It's like some title like that. You can find his book, but he describes his entire process of going through the research from the ancient Chaldeans and incorporating their data into NASA's space models. Isn't that interesting?
Very.
So again, if it's models that make predictions and the thing that's keeping you on the sphere is you think the geometry of the sphere is making those predictions, it isn't. So that can't be something that's keeping you on a sphere because it's irrelevant to the predictions being made. I get where you're coming from though, right? Because you can see in books, online and on the internet, where you've got a nice pretty picture of the sun, darkness, and there's Mercury that looks really, there's Venus, and there's the Earth with the moon around it, and you know, that looks relative, and that one over there, the red looking thing, that's Mars, and so on. Because this is the portrayal of this heliocentric way of explaining the night sky and why we observe the phenomena that we do from the Earth can be very easily mapped and explained geometries, like we pointed out with the moon. But there's no need for it to make any predictions. The predictions aren't made with that geometry involved. They're made on what they've already seen before happen in the night sky all the time. They're all post-dictions. So, can't be that then.
Interesting history, though. The reason why it's called the Saros cycle, Sar, S-A-R, and Saros is a root word, and it means lord or king in ancient Babylonian. This word Tsar is where we get Caesar from, and like with the Russians, the Tsar of Russia. It's also a cognate of the word star, stars in the sky, stars and stars and stars and Caesars. It all comes from the same root. So the ancient Babylonian mystics used to say that every time there is an eclipse, a new king is born. It's the cycle of the kings.
Isn't President Trump born on an eclipse or something?
Yeah, and Christ was crucified during an eclipse.
Yeah. I've heard about some astronomical events that happen in the sky. It's a really interesting subject to me. They've lied about the sky because of what it really means. I don't want to get lost with beans.
Yeah.
It's just this idea of models, beans, right? Again,
Yeah.
we all have, right, had this idea, the image of the Earth in orbit around the sun on TV, on the internet, books and subculture since you were born, since I got here, and I'm 50 years old. I don't expect many people around to be that much older than me. So everyone's going to be younger and you've experienced the same thing. Right? It's the only thing that we got really given. It's hard to think outside that box. But really, if it's models and so on, because we have that image in our head and we think that that image that we get from textbooks is really what's predicting everything that's going on when it isn't. So if that's the thing that's keeping you on the sphere, dude, really that's a weak foundation. That's not a personal thing. I'm just saying that argumentation it hasn't got any grounds. It can't be that because it's not doing the predictions.
Whoever made the textbooks, are they dumb or are they lying on purpose? Like, do you think?
No, intelligent
dumb.
people write fanciful stuff all the time. That's stupid.
People
You're
really
missing
believe this shit, dude.
you're missing the whole point to the conversation, and I appreciate it. But we're talking about the Earth being a globe and it making predictions because of the model that is based about going around the sun and so on, about why we observe things in the sky, like sunrise and sunset, and why there's eclipses, both lunar and solar. The point of the conversation is the geometry of the sphere isn't even involved when making predictions, because they're not even predictions. They're postdictions based upon what we've always seen happen before while standing on the Earth that's flat and stationary.